So a company wants to determine the effectiveness of its Spanish language learning app. The company studied a large random sample of first-year Spanish majors and found that, on average, students who used the app received higher grades in their Spanish classes than students who did not use the app. Based on the design and results of the study, which of the following is an appropriate conclusion? So those who used the app, they scored higher than those who were not using the app, right? They scored lower. And we also know that this was done on only first-year Spanish majors. So it does not apply to any other population. So let's see. Using this app will improve the grades of any college student. That's a very far-fetched claim. This is not even the sample. Using this app will improve the grades of any Spanish major. Not correct, because like I highlighted, it only sampled first-year Spanish majors. Okay. Using this app is likely to improve the grades of first-year Spanish majors. Okay. So this looks correct. The only concern is this is a causation argument. It's saying if you use the app, your grades improved. While we definitely see a correlation, if you use the app, your grades improved. If you did not use the app, your grades were lower. But is there causation? Final option says there is an association between using the app and higher grades in Spanish classes for the first year Spanish majors, but the effect of using the app is unclear, right? So really the choice boils down to these two. This one just says it's an association. This one says causation. You need to remember that for any causation to be proven, basically the experiment also has to assign randomly. So while here, it may very well happen that those who use the app were already doing better or are already advanced learners and thus their grades are better. And those who are struggling in the class chose to not use the app and thus their grades are lower, right? That could be a very possible reason for this, which is why the association is certain, but the causation is not certain. How could the experiment have been designed differently to ascertain the causation? If the makers of the app came to the class and then randomly assigned the app to some people and did not assign the app to some people, and they saw a score increase here and no score increase here, then they could have said that, hey, if you use the app, your scores increase. But not in this case. This could very well be self-selection or bias, that those who were already doing well chose to use the app because they could learn more and their grades were anyway going to be better than those who just ignored because they were not liking the course, not doing well on the course and not likely to do well. So the correct answer is D, where the association is established but not causation. So it says a research study was conducted to determine if a gene therapy is successful in treating color blindness in mice. So we are basically treating for color blindness in mice. From a large population of mice with color blindness, 200 were selected at random. So a fair way to create a sample. Half of the mice were randomly assigned to receive the therapy. So very important to note, there is a random assignment, right? So out of 200, 100 are assigned the therapy and 100 are not assigned the therapy. The results showed that 80% of the mice that received the therapy, right, did show and had some of their ability to see color restored, right? So their color blindness went away. We don't have information on this. Ideally, we should have some information on this, but at least for this group, we saw that color blindness went away. Based on the design and results of the study, which of the following is an appropriate conclusion? So for this question, ideally, in a fair world, you should have information on what happened to the control group also. But in absence of any therapy, we would just assume that their color blindness kind of stayed where it was. But for those who received therapy, their color blindness did decrease. Or at least 80% of the mice had some level of color blindness problem solved. So what are the options? The gene therapy is better at treating color blindness than other available treatments. We have no information on what the other available treatments are. So this is not a valid conclusion. Gene therapy is likely to fully restore the ability to see color for mice with color blindness. It doesn't fully restore. It shows some improvement, some of their ability, and only in some of the mice, 80% of the mice. So again, this is a very far-fetched claim. The gene therapy is likely to improve the ability to see color for mice with color blindness. Likely is a software word. It does restore some ability in some of the mice. So yeah, it is likely that gene therapy will restore some of the ability. The option D says gene therapy will improve the ability to see color for humans. Again, no experiment was done on humans, so you can't make any valid claims on humans.